these are reactions of metals or metal hydrides, metal oxides, non-metal oxides with water. And so first, let's take a look. We've seen this before. We've got a metal, such as a fairly reactive metal like sodium, reacting with water. So switch what could become positive with what is relatively positive. What do you get? You get hydrogen alone, and then you'll get sodium hydroxide. Of course, when you form hydrogen alone, it's not going to be just one hydrogen atom. It will generally form a molecule, its diatomic element, and so you'll form H2, and so then you can balance, and you'll put a 2 here, and a 2 here, and a 2 here. But what if you had a metal hydride? So I say sodium hydride, reacting that with water. Well, you need to do the typical double displacement reaction here, a switch. What is positive, that's a sodium ion here, with what is relatively positive, the hydrogen, one of the hydrogens on water. And so you'll get H2, and you'll get sodium hydroxide. One way to view this is you are dropping an ionic compound into water, and so you're releasing two separate ions, sodium ion and hydride ion. Now, hydride, you'll later learn, is a very strong base, and so it will pick up a proton from water, forming that H2. Fairly similar actually is reacting metal oxides with water. So say potassium oxide. So again, you switch a cation, what is positive, with what is relatively positive, and soon that only releases one of those potassiums. You get one potassium left, and now an O with an H, KOH, and you'll get a K and then an OH. So in fact, you form two potassium hydroxides here, and you're balanced. Another way to view this is potassium oxide. If you dissolve this in water, that gives an oxide ion, which is a very strong base, and so it will pick off one of the protons from water to form hydroxide. Another one, here's a non-metal oxide with water. Non-metal oxides, you don't have ions here, so instead you have molecules. So this is sulfur trioxide. You've got covalent bonds here, which are not so easily broken. In fact, what occurs here, and you'll learn about this later, is you've got water, and it's got an oxygen, which is relatively negative, and then you have a sulfur here, which is relatively positive. And so you have water acting as a Lewis base, and it's going to have a lone pair of electrons donate to the sulfur of sulfur trioxide, which is acting as a Lewis acid. And so you actually kind of stick that water onto SO3, and soon you have H2SO4, one more oxygen, two hydrogens. That's quite simple. If you've only got one non-oxygen nonmetal, it's very easy. Just add two hydrogens and an oxygen. But what if there are two or more non-oxygen nonmetals? Then you need to predict the acids that will form with a little bit more complexity. So here are two different nitrogen oxides. So which one will form HNO3 and which one will form HNO2? These are common acids of nitrogen. You need to pay attention to the oxidation state of your non-oxygen nonmetal. You see, when you have some Lewis base reacting with a Lewis acid, that is not a redox reaction. So no atom is oxidized or reduced. You're just kind of forming new covalent bonds. And so what that means is if you find the oxidation state of this nitrogen, say, you'll have that same oxidation state of nitrogen in your product. So what's the oxidation state of this nitrogen? Well, you pull out the algebra. 2 times x plus 3 times minus 2 is equal to 0 here. So 2x minus 6 is equal to 0. And so 2x is equal to 6, and x is equal to plus 3. So this nitrogen, its oxidation state is plus 3. That means your product must also have a plus 3 oxidation state. So what's an example of a nitrogen oxo acid with a plus 3 oxidation state? Try HNO2. Check your math. Hydrogen, is plus 1, and there's only one of it. Nitrogen, what if it's plus 3 and you have one of it? And then 2 minus 2 is on oxygen. Will that give this 0 charge for the compound? Yes. 1 plus 3 minus 4 is equal to 0. So yes, this nitrogen is plus 3. And then N2O5, the oxidation state of the nitrogen is plus 5. So try forming HNO3. Yeah, that nitrogen has an oxidation state of plus 5 as well. And so those are a little bit more difficult. So what would litmus paper look like if you were to dip that litmus paper in water with these compounds in them? Well, if you put these nonmetal oxides into water, you would be forming acids. And so the litmus paper, if you were to dip it in that solution, that acidic solution, that litmus paper would turn red, or at least remain red. But what about these other cases? Well, if you put it in a solution of, say, potassium oxide in water, that would give a potassium hydroxide. That's a base, so your litmus paper would be blue, because you would have a basic solution. Similarly for metal hydrides, and similarly for just metals with water. Thanks for watching, guys.